So starting with the discussion of pop quiz, which was related to states of the matter in the atomic structure. In the first question, a substance M is solid at 30 degrees and the substance is heated to 80 and its temperature measured as it cooled down. The cooling curve is shown. Look, whenever, so it means, like example, at 30 degrees, it was solid. So when the temperature was 30, the substance was solid here. Why at this point, why at this point the temperature is not changing? Look, there might be two reasons for a temperature not to change. One is maybe there is a change in state. If a substance is changing a state, there will be no change in temperature. That is one of the reasons. Or the second reason is it might be in thermal equilibrium with the surrounding. Like once the temperature of the substance is same as the temperature of the surrounding. Like example, if I say room temperature is say 25 and this substance temperature was 40. So when this substance temperature is 40, it will lose its energy to the surrounding and eventually what will happen? The substance temperature will be 25 as well. Once they are in thermal equilibrium, like the surrounding temperature and the substance temperature is same, the object or a substance will not change the temperature and that is refers to a thermal equilibrium. It does not mean a substance is changing a state. It means it reaches a room temperature. That's why it is not further changing the temperature. So as I mentioned, this is solid. At this point, it is solid. So when the before this, like where the temperature is constant, it means there was a change in state in this region. So what was the change in state in this region? So at this region, the liquid was converting into a solid and we'll have a liquid here. So maybe you get confused by looking at this temperature that the temperature is constant here. Why the temperature is constant at this region? It's not because there is a change in state. It is because the substance reaches a thermal equilibrium or the substance temperature is same as the room temperature. That's why it is not changing the temperature. So when we check the options, the question is between which time the substance is freezing or changing the state. So we are left with only this section. So it will be liquid here and a liquid is turning into solid. So between Q and R, the substance is freezing. So B should be the right answer for this. Is it clear, this one? So whenever the temperature is constant, a temperature of a substance is not changing, what might be the reason? Number one, there might be a change in state. Number two, it might be in thermal equilibrium with the surrounding, or you can say the surrounding temperature and the substance temperature is equal. In question two, which gas has the fastest rate of diffusion? So you have to check which is having a lower relative molecular mass. So for this, you have to use a periodic table in exam. You will have the access to the periodic table. So when you check argon, argon is 40 here. So argon is 40. When we check C2H6, so carbon is there, which is 12, and hydrogen is there, which is 1. So the total mass of C2H6, this will be 12 multiplied by 2 plus 1 into 6. So this will be 24 plus 6, which makes 30. HCl, hydrogen is 1, and when you check the periodic table, chlorine is 35.5. So total will be 36.5. And in hydrogen sulfide, hydrogen 1 multiplied by 2, and sulfur is 32. So it will be 2 plus 32 will make 34. So which is having the lower relative molecular mass, that is B, C2H6 is having a lower relative molecular mass. So it will diffuse faster. So the gases which are having a lower relative molecular mass will move faster than the gases which are having a higher relative molecular mass. In question 3, there are two stable isotopes of the bromine. With a one isotope is having a mass number of 79, another one is 81. Which statement is correct? The isotopes have the same number of neutron. They won't have same number of neutron. Isotopes have same number of proton and electron, but different number of neutrons. Isotopes have different chemical properties. That's wrong as well. Isotopes will have the same chemical properties because they have same number of electrons in the outer shell, the last shell. Isotopes have different number of proton. That's also wrong. Isotopes have same number of proton because proton is the identity of the element. You can identify the element from the proton number. Every element is having a unique proton number. So proton number for, because these are isotopes of the bromine, so they must have the same proton number. Isotopes have the same number of outer electrons. That's right. And because they have same number of outer shell electrons, that's why they will have the same chemical properties. Because chemical properties of atom or an element depends on how many electrons are there in the last shell. Because chemical properties means the way they react. So it depends on how many electrons are there. If they have the same number of electron, they will react in the same manner. That's why D is the right answer here. In question 4, all gases diffuse, choose from the list of the formula the gas which diffuse most quickly. So the gas which is lighter means which is having a lower relative molecular mass will diffuse faster. So again, you have to use a periodic table. So when you use a periodic table, carbon is 12, oxygen is 16. So the sum will be 28. Here, when you check carbon dioxide, carbon is 12 and oxygen is 16 multiplied by 2. So 32 plus 12, the sum will be 44. For a methane, CH4 is a methane gas. So carbon is 12 and hydrogen is 1 multiplied by 4. So when you sum, you will get the total as 16. For nitrogen dioxide, nitrogen is 14 plus oxygen is 16 multiplied by 2. So 32 plus 14 will make 46. So the sum will be 46. And for sulfur dioxide, sulfur is 32. You have to use the periodic table. And oxygen is 16 times 2. So 32 plus 32 will make 64. So the total mass here will be 64. And you have to check which will diffuse most quickly. The one which is having a lower relative molecular mass. So which is having a lower relative molecular mass? When you check this, so this one is CH4 is having the lower relative molecular mass because it's 16. So we'll draw a circle around the one which diffuse faster, that is CH4, and reason is that because it is having a lower relative molecular mass or a mass of a molecule. Is it clear? Question 4. Then in question 5, lithium has two naturally occurring like types of atoms. Lithium 6 is there and 7. State the name given to an atom which are of the same element with different nucleon numbers. So what we call them as isotopes. Complete the table to show the number of the proton. As I mentioned, for every element, the proton number is unique. Like every element is having its own proton number. So for this, you have to use a periodic table and check the periodic table. What is the proton number of lithium, Li? Lithium is a group 1 element. So don't bother about the mass number. Mass number can be different because we may have a different isotopes, but the proton number is the identity. Atomic number of every element is unique. So lithium is 3. So every lithium isotope will have a proton number 3. So this will have proton number 3. The other will also have proton number 3 because proton number is identity of the element. So they have a unique proton number. How to work out a neutron number when the nucleon number minus the proton number, like 6 minus 3, so we get 3, 7 minus 3, we get 4. How to know the electrons? Because this is an atom, there is no charge written, so net charge is 0, means it should have equal number of proton and electron. Here the net charge is plus or a positive, it means it has extra proton, one extra proton, then electron. So how many electrons should be there? So it should have 2 electrons. So that's how we complete. So proton number is the identity of element. So you have to use a periodic table. If any element symbol is given, you will use a periodic table and find that element. So this was a pop quiz which was related to states of the matter and atomic structure.